Welcome you all for the session. In this session, we are going to see how the circle diagram is drawn for induction motor and how we can calculate various parameters by using circle diagram. Before moving to draw the circle diagram, we need to conduct certain tests for getting the raw data. So the test to be conducted for getting data are no load test and block rotor test. First, let us discuss in detail about the no load test. So, the induction machine is made to run at no load at rated voltage, and the voltage V0, the no load current I0, and the no load power P0 is calculated and is noted. And from that reading, we need to find the value of phi naught. That is the no load power, no load angle phi naught, which is equal to P0 divided by root 3 V0 into I0. Then the blocked rotor test. So here in blocked rotor test, the block here what we short circuit test is otherwise called a short circuit test. By conducting blocked rotor test, the short circuit voltage, current, and the PSC three values will be calculated, and here with the help of this the phi SC, that is the phase angle at blocked rotor condition, will be calculated, and the current drawn if the rated voltage is applied to the blocked rotor test, ISN, which is equal to ISC into V0 divided by VSC. V0 is no load voltage, VSC is voltage applied at short circuit condition. Then the power input at rated voltage of motor in blocked rotor test, PSN, is equal to PSC into V0 divided by VSC the whole square. These values first you need to calculate. So now for drawing the circle, this is the circle diagram. Here you can see the circle diagram. So this is the circle diagram. So we are going to plot this. Let us see the step is first draw a horizontal axis OX. So we are going to draw a horizontal axis OX and the vertical axis OY. Here the vertical axis represents the voltage reference. So this is going to be your voltage reference. Okay, the vertical axis is going to be your this one. So we are going to mentioning it as V. This OY is going to be your voltage axis. Okay, so let us plot this. See, this is the horizontal axis and this the vertical axis. This need to be plotted. With suitable scale, draw a phasor OA with the length corresponding to I0. So see, vertical axis and horizontal axis, then you have to plot OA. This OA is corresponding value of I0. Now you need to make an angle. So you need to take an angle. This angle is phi naught. We have already calculated the value of phi naught. So you have to plot that phi naught over here from the vertical axis and draw a horizontal line AB. Now you are going to draw a horizontal line AB. So this is what you are going to do. So that's all in this step. Next step. So draw a OS equal to ISN at the angle of ISN. So next you are going to draw OSN. So you are going to draw this OS. See, you are going to extend this from this phi SN. See how it is going to be done. So this OSN. Okay, so this is what you are going to do. Next, draw a perpendicular bisector of AS. So now you are going to draw a perpendicular bisector. So this is AS line. You are going to bisect this line. So you will be getting a cross line like this. So just you are going to take a half. So while taking this, you will be getting this line. So here you can see a line, isn't it? So I'm going to draw that line. Just I have bisected the line. So with CS center, draw a semicircle passing through AS. So still this we have drawn. Now CS center. So now you have to draw a circle. Passes through A. So always the circle passes through A. If not it doesn't pass through the A, you have made some mistake. You need to recheck your diagram. So now I have draw a semicircle which passes through A. From the point S, draw a vertical line XL. So now we need to draw a vertical line XL. This is SL. See, this is the point S and this is the line crossing through this vertical. See, SL is drawn. So next you need to mark the point K. See here you have a K point. So in the question, or they will be mentioning the rotor copper loss and stator copper. If it is equal, just you need to bisect this line. If suppose if they have mentioned something like that, if the rotor copper loss is twice than that of stator copper loss, based on that ratio, you need to mark the point K, and you need to draw you need to join this K with respect to A. That is what you are going to do. See, that is the point say. For wound rotor machines, the equivalent rotor resistance R2 can be found out and divide SL at a point K, that is they are equivalent. So that is as rotor resistance is equal to stator resistance. So if stator copper loss is ISN and stator winding is R1, then rotor copper loss is equal to total copper loss minus stator copper loss, and divide SL at a point K if both are equal. Now what we are going to do is, for operating point P, from this operating point P, draw a vertical line. So this from this point I am going to draw a vertical line that bisects this E, F, G and D. Okay. So for a given operating point, draw a vertical line that we have plotted, and from this line we are going to calculate. PD is the input power, P is the output power. Why we call them as power line? Because EF the rotor copper loss, FG is the stator copper loss, GD the constant loss, that is iron loss plus mechanical loss. Okay, so once you draw the circle diagram, from this we can calculate. This are the rotor copper loss, this is stator copper loss, this is the fixed losses, and here PD, this P2D, if you measure, you will be getting something called as the input power. PE, if up to this green line, these things gives the output power, and EF, so here this will give the rotor copper loss, FG gives the stator copper loss, and GD gives the constant loss. Okay, so with the help of this one is called the loss line, this one is called the power line. Next, you can also calculate efficiency, power factor, slip and starting torque by using these formulas. Say efficiency of the machine eta is equal to PE by PD, and power factor of machine P is equal to cos phi 1, and slip of machine is EF by PF, and starting torque is SK. Thank you.